We will talk about cone penetration test and PCPT, piezo cone penetration test. In the context of offshore geotechnical soil exploration reports, cone penetration test and PCPT, piezo cone penetration test, refers to two types of in situ testing methods used to evaluate soil properties. So here in situ, these two are not lab tests; these two are in situ testing methods. So what do you mean by, what does CPT stand for? CPT stands for cone penetration test. What additional feature does PCPT have compared to CPT? PCPT includes pore pressure sensor, allowing for measurement of pore water pressure in addition to soil resistance. So that means that in case of PCPT, we have the option to measure the pore water pressure compared to soil compared to CPT. Both measures the soil resistance, but in PCPT it measures, in addition to the soil resistance, pore water pressure also it measures. What type of data does CPT provide? CPT provides on tip resistance and sleeve friction. So CPT method, if you see, involves pushing a cone-shaped penetrometer into the ground at a constant rate. So here in case of PCPT, method is similar to CPT but includes additional sensors to measure pore water pressure in the soil. So in case of CPT, the data collected will be measures resistance to penetration, which helps determine the soil stratigraphy and mechanical properties. Applications commonly used for assessing soil types and bearing capacity and consistency. In case of PCPT, data collected provides information on the soil strength and also the pore pressure, which is crucial for understanding effective stress and soil behavior under loading conditions. So this effective stress, if you want to understand, we need to have the measurement about the pore pressure. This is particularly useful in saturated soils where pore water pressure can significantly influence stability and consolidation. So in terms of instrumentation, PCPT includes pore pressure measurement and CPT does not. So CPT does not have any pore pressure measurement, additional sensors does not have. So PCPT offers insights into both soil strength and groundwater conditions, whereas CPT focuses primarily on soil resistance only. So here we can see this methodology setup. If you see, cone penetrometer is attached to hydraulic pushing system that drives it into the soil at a controlled rate of 2 cm per second. And then measurements. The cone is pushed. As the cone is pushed, it measures resistance to the soil at the cone tip. So resistance of the soil at cone tip, that's the QC, and sleeve friction, frictional resistance along the sides of the cone. So in case of cost effectiveness, if you see, this is less expensive than other in situ methods. Continuous data collection allows for quick profiling of soil layers and causes minimal disturbance to the soil, preserving natural conditions. Limitations, if you see, no pore pressure data, does not provide information on the groundwater conditions. Limited to certain type of certain soil types, performance can be less reliable in highly variable or very soft soils. So summary of difference, if you see CPT and PCPT, in type of data we are getting tip resistance QC and sleeve friction. Here in PCPT we get tip resistance, sleeve friction and pore water pressure. Excessively additional data is pore water pressure. Instrumentation, simple cone penetrometer. Here piezo cone with pore pressure sensor. Here only simple cone penetrometer in CPT. In PCPT we have the piezo cone with the pore pressure sensor. Cost wise is generally lower in CPT. PCPT is higher due to added sensors. And soil type, effective in variety of soils, more effective in saturated soils. PCPT more effective in saturated soils. Analysis complexity wise, if it is relatively straightforward in CPT, and PCPT it's more complex due to pore pressure conditions. So here if you see in PCPT, pore pressure, setup is similar to CPT, but includes piezo cone, includes pore pressure sensor at the cone tip. At the cone tip, pore pressure sensor also there. In addition to tip resistance and sleeve friction, it measures the pore pressure exerted by water in soil pores, allowing for assessment of effective stress. So here we can see, why is pore pressure measurement important in geotechnical studies? Because pore pressure measurement is crucial for understanding effective stress and soil behavior in saturated soil condition. If you have soil condition, saturated soil condition, then pore pressure, measurement of pore pressure is important. So why is pore pressure measurement important in geotechnical means? This is the reason. Which is generally more cost effective, CPT or PCPT means CPT is generally more cost effective than PCPT because it does not have any additional sensors. In what type of soil CPT is less reliable? CPT can be less reliable in highly variable and very soft soils. What are some of the typical applications of CPT? Typical applications include soil classification, bearing capacity assessment, and site characterization. How is cone penetrometer pushed into the soil during CPT? So cone penetrometer, how is it pushed? The cone penetrometer pushed into the soil during CPT. So it is pushed into the soil at a controlled rate, that is typically around 2 cm per second. What makes PCPT better suited for saturated soils? PCPT's ability to measure pore water pressure. It can measure pore water pressure, so that allows the pore water for a more comprehensive understanding of soil behavior in saturated conditions. Because it has the ability to measure the pore water pressure. That's the reason it becomes more capable for understanding the behavior of saturated soil conditions. So that makes PCPT better suited for saturated soil conditions. So what does QC represent in CPT? QC means it's a tip resistance encountered by the cone during penetration. When the cone is pushed into the ground at a constant of 2 cm per second, it is encountering the tip resistance. That tip resistance is called QC. What type of analysis is crucial in PCPT for understanding soil stability? Effective stress is crucial for understanding the soil stability in saturated conditions. So in saturated conditions, if we want to know the soil stability, we need to understand how the effective stress is varying, what's the effective stress values, all these things we should know to understand the soil stability in saturated soil conditions. Is PCPT more complex to analyze than CPT? Yes, PCPT is more sophisticated, requires more sophisticated analysis due to pore water pressure, interaction between soil strength and pore pressure. There is interaction between the soil strength and pore water pressure. So because of this we need to have sophisticated analysis. So PCPT is little complex than CPT, because in CPT it does not consider the effect or interaction between the pore water pressure and soil strength, but only in PCPT it is possible. What is sleeve friction in the context of CPT? Sleeve friction is the frictional resistance measured along the sides of the cone during penetration. So when we are pushing the cone penetrometer on the ground, the sides of the cone, it will experience some frictional resistance. So that frictional resistance is measured. That measured frictional resistance along the sides of the cone during penetration is called sleeve friction. So can CPT provide information on groundwater conditions? No, CPT does not provide information on groundwater conditions. That's where PCPT is beneficial. What kind of data interpretation is needed for PCPT? Interpretation of PCPT results involves understanding the relations between soil strength and pore water pressure. What is one major advantage of CPT over PCPT? One major advantage of CPT is simplicity and lower cost compared to the PCPT. How does the equipment for PCPT differ from that of CPT? Because PCPT uses piezo cone that includes sensors for measuring pore pressure, while CPT uses standard cone penetrometer. So CPT means standard cone penetrometer. Piezo cone penetrometer means it has the additional sensors to measure the pore water pressure, and that's how the equipment for PCPT differs from CPT. How does the equipment of PCPT differ from that of CPT? Then you can answer like this. What is a common engineering application for PCPT? PCPT is commonly used for slope stability analysis and predicting settlement under load. How does PCPT data assist in foundation design? PCPT data provides detailed insights into soil behavior, which is essential for designing complex foundation systems. What is the purpose of both CPT and PCPT? Primary purpose of both is to characterize subsurface soil conditions for engineering and construction projects. So we will have some meanings of meeting analyze. Alright team, we need to finalize our exploration strategy. Let's dive into the technical parameters CPT and PCPT. Can you start by outlining the typical parameters we need to collect during CPT? Sure, for CPT we typically measure tip resistance. This is the resistance This is the resistance offered by soil at the cone tip. It's crucial for determining the bearing capacity. Sleeve friction. This measures the friction along the sleeve of the cone, which helps us differentiate between soil types. So differentiate between soil types, we can take frictional resistance, and determine the bearing capacity, we take tip resistance. So bearing capacity, and to differentiate between the soil types, these two measurements QC and FS is there. Total cone resistance, it's a sum of tip resistance and sleeve friction, can provide the insight into overall soil behavior. And don't forget that there is a friction ratio. It is calculated Fs by QC. Fs by QC. This is a ratio. This ratio is key for classifying soil type. So frictional ratio is important for classifying the soil type, understanding their behavior under load. Whether this Fs, if it is more, frictional ratio will be more. That means it's like a kind of clay or kind of thing, or a soil friction, mainly friction type, soil type. We can classify it. For that, this friction ratio is important. For cohesion-less soils, low RF indicates sand. So for cohesion-less soil, low RF indicates sand, while high RF indicates clay. High RF means sleeve friction is higher compared to tip resistance. So high friction ratio indicates clay, low friction ratio indicates sand. So we can understand we should also consider depth of penetration, typically aiming for 20 to 30 meters, but it can vary based on site conditions. So friction ratio is important parameter. By that we can understand whether it's a soil type is clay or sand. But how do we understand that? Based on the friction ratio. If the friction ratio is higher, it suggests that it can be clay. If the friction ratio is low, it suggests that it's a sand. Looking at our notes, great points. Now when we talk about PCPT, what specific parameters do we need to measure?